easy for visually you to pick out the highest point of the graph and where it ends at the highest point. So the example here, it says write the equation of the sinusoid. That is actually the name of a sine cosine graph. So like the name of a quadratic graph is a parabola. The name of a linear graph is a line. The name of a x cubed graph is a cubic graph. So this is called a sinusoid. It's not called a cosine graph. It's not called a sine graph because it actually could be either or. So any curve, a wave, could actually go with sine and cosine, just depending on where you're looking at the graph. So below is like a reasoning process as to like what you should be thinking about as you're trying to write an equation. But no, you're not going to do like all those little blanks for every single problem because some of them kind of just combine together. But the first thing says write the general equation. Let's use cosine since it starts at a high point and we can find cosine easily. So the cosine equation, I'm just going to write it again here. A cosine bx minus c and then plus d. It's always a minus sign. That's the standard form of any equation we've worked with, except that it said x minus h in parentheses instead of bx minus c. That would be the standard form of the equations. All of the equations you did last year and this year always have that same form, the minus sign in the parentheses. So the only thing what we're going to do with this equation is just tweak it a little bit to make it actually easier for us to solve for. And that would be this b value here. So we're going to factor out the b value so that it is separate from the parentheses. So we still have a, we still have cosine, except if we factor b out, so that we're writing it outside of the parentheses. Factoring is another way of saying divide by the GCF, if there were a GCF. We would have inside the parentheses x, and then because I'm dividing by b, we would have c over b left in the parentheses. Bless you. So if we do that and we create this c over b value in the parentheses, what is c over b? Chelsea? The phase shift. So that value represents the phase shift. And that'll help us because then we won't have to do extra work to find c by itself. Visually getting a phase shift is really easy. You can't just visually see a c value, you can see the phase shift. And as we work through, you'll kind of notice where all the pieces are. So we're going to leave the b outside of the parentheses. Inside the parentheses, we're going to use the actual phase shift value. So again, like there's a lot on this page, a lot of little blanks to fill in, but we're not necessarily going to do all of that for every problem. You're going to start combining things together. But this is just for you to get a general idea of where information comes from. So the first thing we're going to do is try and find b. B is with the period, so the period and b go together. We use b to find the period. In order to do that, it says where does the cycle begin? So if you look at the picture above, if we're using cosine, it starts at the high point. So that means our graph for cosine starts at the maximum value. The first point of cosine is usually at 0, 1. So it always starts up high at the y value of 1. Well, this one's starting at a different y value, but that's still the start of the graph. It ends after it comes down and goes back up to that highest point of the graph. So a cosine graph, one cycle of it, one rotation around the unit circle, is supposed to look kind of like a cursive V. So what I have up here, kind of from point to point, is a cursive V. So it says, where does the cycle begin? Chelsea, what's the x value that it begins at? 3. And the x value that it ends at is? 23. So the horizontal stretch of the graph is what we call the period. So Eris, if one starts at 3 and it ends at 23, the period would be? 20. So the distance from the first to the last point, you have 20 spaces in between, 20 units in between. So we're going to use this number to find b. This is your period, but how can we find the b value using 20? Yeah, or I'm going to just use a b in there. So 2 pi over b will be equal to the period. That's our little formula to find the period. So we usually plug in a b and then we calculate the period, but we're going to do this backwards. So we're going to try and find b because we know what the period is. It's 20. That's the horizontal stretch of the graph. So if you solve the little equation, Virginia, we would have 2 pi equals 20b or B is pi over 10, right? Pi over 10. Because you're dividing by 20, that's a sloppy 2, and you end up with pi over 10. So exact value with the pi, we're not getting decimals. So even though the distance from start to stop is 20, the B value, which goes into our equation, is pi over 10. So that would be the first letter that we found out of 4. We've got to find 4 of them. So here's the first value. So then the second thing it wants us to find is D. So, and it says, in words, what is D? So think about like the graph. What does the D value mean to the graph? Virginia? It's the vertical shift. Yeah, so it tells us how far up or how far down the graph goes. Usually it sits on the x-axis, but the D value is that vertical shift. It is also the middle horizontal line of the graph, or it's the halfway line, the halfway point of the graph. So it's a horizontal line that cuts the graph in half. Because you should have half of the graph above it and half of the graph below it. So if you look in your graph that's shown, there is a horizontal line. That horizontal line is our D value. We need to find that value. So how would you kind of describe how we could go about finding that value? Chelsea?
You find the distance between the highest and lowest points and then divide it.
Yeah, because we want the middle of the graph. So find the distance between the highest and lowest points, which means we're taking the max and the min, adding them together, and then dividing it by 2. So the D is the middle. Anytime you want to find the middle, you want to find the average between the largest and the smallest values. So add them together, divide them by 2. So this highest point was a 56. The lower point, the lower bound, is negative 38. So how do you calculate D? Well, you take those two numbers, add them together. Use the negative 38. Don't make it positive. Keep it exactly as it is. So Grace, D would be 9, yeah. So 56 and negative 38 make 18. When you divide it by 2, you get 9. So when you look at your graph, like just check to make sure that number makes sense. So if this now is at y equals 9, it makes sense because it's definitely closer to the x-axis at y equals 0 than it is up to 56. So that distance should be kind of make sense with what you have in your graph. The fourth value we're going to find is, or third value we're going to find is A. And again, kind of think in your mind, like what is A talking about? Libby, what does A mean in the problem?
A is the amplitude.
A is the amplitude. And what is the amplitude?
It's like the distance between the max or min to the like center.
Yeah. So the distance between the max or the min to the center. And then it says show the calculation how we can find A. So if you look at your diagram, this here is A. The distance from the max to the center or the distance from the min to the center. That distance is the same. So if we have a 56 for the max, the center is 9. Libby, the A value would be
47.
47. So find the center of your graph. What does it take from you to get to the center up to the top? Well, the center's at 9. 9 plus 47 gives us 56. Or what does it take to go from the center to the bottom? So it's that distance, the vertical distance. Amplitude is our vertical stretch of the graph. How high is it stretching to the top? The very last thing we have to find is C over B. So we're not finding C because we factored that B out so that we could just find the phase shift. So again, it says in words, what does the phase shift, or how does the phase shift affect the graph? Chelsea?
It's how it moves it left to right.
Yeah. So however it moves it, left or right. It is also the starting point of our graph. That's where the graph begins. It begins at your phase shift. If there isn't a phase shift, then the cosine begins at 0, 1. But if there is a phase shift, then the cosine is moving away from the 0 and starting at a new place. So if you look at your graph, the phase shift is really easy to see because wherever your highest point is, that first highest point, that's your phase shift. That's how far you're shifting from the point that's usually on the y-axis. It usually starts at its y-intercept. So your phase shift is how far it shifts left or right. Well, this graph is shifting to 3. So our phase shift is 3. That's C over B. It's not C and it's not B. It's that whole C over B value. So when you have that number, you can then just directly plug it into your equation. We're not actually going to find the value of C by itself. So it saves us like a little extra step. So then the last part says write the equation. So if you look above to the 4 different things we found, grab your A, your B, your phase shift, and then your D. And you're writing the equation in cosine form because we chose the first highest point and the last highest point. And that represents the cosine of our equation. So 47 is what we found for A. Then we have cosine. B was pi over 2, 10, not pi over 2. Not 20. So 20 was the period. We calculated B to be pi over 10. And then the phase shift is the only thing that goes in the parentheses. And that's this 3, and it would be x minus 3. It's a minus because the standard form of the equation is minus. So when you plug that 3 in, you have an x minus a positive value of 3. And then the last thing, the D value, I think was 9 from the other side. Or above. Questions? So we're going to go through another one together. It's just on the back of this page. There are 6 graphs. So we'll work through another one of them together, and then I want to show you how we can use the same graph to come up with a sine equation. You can come up with a really infinite number of equations for one graph, depending on how long you extend the graph. But we can all create a different equation for a single picture, a single graph. So this one says, write an equation of the sinusoid sketched. So if you flip it over to the back and look at the first one. We're not going to work through all those steps because we can pretty much combine them together, but you still have to find 4 things. So the first thing we found was the period. And it doesn't have to be the first thing you find. You can find that last too, because you could focus on the other values. But that's just what we found first. So what do we need to do to find the period, or what is the period of this graph? Virginia? Right, highest to the highest point. So you need to mark, or at least locate, the highest to the highest point. That will be the first thing when you're looking at the graph. So pick the piece of the graph where you have the highest to the highest point. And then we're finding the different distance from that point to the next point. The period is horizontal, so we need to use x. So Virginia, the distance from 20 degrees to 200 degrees is 180. Now notice that is degrees. Instead of having a pi in it, doesn't have a pi, we have a degree value. So your period is the distance from the first highest point to the second highest point. Using the period, we want to find B. So usually the period is equal to 2 pi over B. Sorry, this is not my period. There we go, 180 degrees. But what do you have to do different with that formula? Aisha?
Put 2 pi in degrees.
Put it what?
2 pi in degrees.
Yeah, we need to put 2 pi in degrees because 2 pi is radians, but the values we're given for the angles are in degrees. So Asia, 2 pi is the same as 360 degrees. That's gonna be for 1 and 2, you're gonna have to use 360 instead of 2 pi, because 1 and 2 are graphed in degree form, Libby.
So are you not allowed to convert it in the radians?
However it's given is how your answer should remain. So it's the same thing with an angle. If it's given in radians, your answer should be in radians. If a graph is given in degrees, your answer should be in degrees. So multiply by b, divide by 180, and you end up with b being 2 degrees. That's just solving that little equation for b. So now we have b. What else can we find? What should you find next? Chelsea? D, yeah. So you need D in order to get A. So we want this value here. That's our D value. That's going to be the second thing we can try and think about finding. And D is equal to the max, which is 15, plus the min divided by 2. Because D is the middle of the graph, the halfway point of the graph, from max to min. So 15 and 3 make 18 divided by 2 gives us the value of 9. So now D is equal to 9. What else can we find? We know D. Chelsea? A. So now that we know D, A is the stretch from D up into the max. What does it take for you to go from 9 to 15? 7 is 9 plus 6. Started out with 4, huh? That's all right. 6? Are you good with 6? Okay, so 6. And then the last thing we need is the phase shift. So we have A, we have D, we have B. We're going to get that C over B value. And that's just looking at the x value, where that point, the maximum location is. So our max is right here. The x value associated with that is 20 degrees. Questions? So, I mean, we still found all those 4 pieces, but we didn't really fill in all the extra blanks. So, writing your equation. A is 6, we have the cosine. The B is 2 degrees. And then x minus the phase shift is 20 degrees, because that's where the graph is starting. Then the last thing, the D value is 9, so plus 9. So for this graph, I want to also write a sine graph, because we're going to be asked to do both. So by looking at this same graph, cosine starts at the top and ends at the top. Where would the sine graph start? Chelsea?
At the top because the bottom. Right.
Say it again.
Wait, never mind. But it's right at the top.
Think of it at the angle of 0 on the unit circle. What's the sine?
It starts at the origin.
It starts at the origin. So this one is not going to start at the origin, but it's going to start on this line here, on the side, that D line, because that's kind of the centering of the graph. So the sine starts in the middle. The cosine starts at the top. So if you find in the middle, right here, that's where your graph would begin, in the middle of the lines, the curves. And then it goes up high, makes a full mountain, or the top of the curve, and then it goes down low. It also ends in the middle. So cosine starts in the middle and ends in the middle. I'm sorry. The sine starts in the middle and ends in the middle. The cosine starts up high and ends up high. So when you're writing a sine graph, would the period change? Would the distance from the first point to the last point change? And calculate it. Like, so if this starts now at negative 25 and ends at 155, what is the distance from negative 25 to 155? What's that space in between? Libby?
180.
180. So the period is not changing just because we have a sign graph. Does the height of the graph change? No, it still goes up to 15. So that's not going to change. So the amplitude is the same. The b value is still the same. The middle of the graph is still the same. When you write a sine equation, the only thing that changes is where the graph starts, because it's starting in the middle instead of starting at the top. So the sine graph, and I have a million things circled over here, starts to the left at negative 25. The phase shift is the only difference between a cosine and a sine equation. So the sine equation is going to say x minus negative 25 or x plus 25 degrees. But the other numbers are exactly the same. The distance is still the same, the height is still the same, the middle is still the same. It just starts at a different location. So when you write a sine graph, you pick a different starting point, but everything else is the same. Questions? So we're going to turn to another page, but if you just look down at number 5. So number 5 starts at its peak, but you only have half of it because it's supposed to end up high. What would you do for the period if you only know half of it, Virginia?
Just double it.
Just double it. So for number 5, the period, well, right now we have 100 to 900. So you're going to double that then because everything is symmetrical. It's all evened out. So half the graph, double it to get the other half of the graph. Or you could create the other half of the graph. You could extend it if you wanted to. Questions? Okay, so part of your homework would be to finish those 5 problems. So you're going to write one equation. You don't have to write 2, just one equation to finish those 5 problems. And then I'd like you to flip to page 15 because I want you to look at the first problem because its wording is a little different. So your other part of your homework is on page 15. There are 4 graphs that you're going to come up with equations. So most of it is just writing equations. So you're going to see the graph, come up with the equation, and the first 2 don't even have phase shifts in number 2. But number 1 is different because number 1 actually kind of takes us back to what we did in section 4.4. Number 1 says for us to use the graph of the sine, so we're actually going to try and use the sine graph to help us find the real numbers of x. X is the angle. So our goal is to find angles for x in between negative 2 pi and positive 2 pi when y is equal to negative 0.75. We did problems like this. This was like the last question of your quiz. It said the sine was equal to negative 1/2 and you had to come up with the angles when the sine was negative 1/2. Well, negative 1/2 is on the unit circle, so that's really easy to do. 0.75 is not a number from the unit circle. So I'm actually going to show you how to use your calculator for this. So if you'll take out the calculator. Actually use the calculator. We're going to graph sine with the calculator, and we're going to use the technology to help us find some angles. So on your calculator, not that. There we go. So I want you to type in sine x. So you're using the sine button, the sine function. And then in y2, we're going to type in what we want the y value to be. So it said find x when y is negative 0.75. So we're going to type that in because we're graphing sine. And we want the y of the sine to be negative 0.75. So we might as well use the calculator to help us get that. Now, before you hit graph, go to the mode. Make sure your mode is in radians. That's really important because we're trying to find an angle in radians. So check your radians for mode. And then go to the window. just changing the calculator to radians doesn't necessarily give us a nice graph. So because the x value is supposed to go from negative 2 pi to positive 2 pi, we're going to change our x value to be what it's asking us. So we're going to make this negative 2 pi. Because now I'm forcing the graph to be in radians as well. And the max for x is going to be positive 2 pi. And again, that's just going off the directions. They said find x values between negative 2 pi and positive 2 pi. So we want x to be in that location. So we're going to just restrict the graph to be in that location. And then the last thing I'm going to do is just change y. If you don't, your graph is really squished. Usually, what's the smallest y value for sine? So think of the sine graph. What's the lowest y value for a typical sine graph, Virginia? Negative 1. So I'm just going to make it negative 2 so that it goes a little bit below. And then the highest is usually positive 1, so I'll just make that positive 2. Otherwise, the graph is too narrow and you won't get much of a curve. So if we restrict those y values, then you get to see a nice curve. This is what our graph looks like. So that when we first graphed sine back on Monday, we graphed that basic sine graph. This is what we got when it didn't move and it didn't stretch and it didn't shrink. So your goal is to find when y is negative 0.75. That's this line here. How can I find these values with the calculator? Virginia? Yeah, so when you do second, and mine apparently is not going to work. So if you hit second trace and then you're doing the intersection, there are two values in the positive 0 to 2 pi. There are two values from negative 2 pi to 0 because sine is positive in quadrants 1 and 2. It's negative in quadrants 3 and 4. So down here would be quadrant 3 and quadrant 4 if we took this and put it back on the unit circle. Questions? So you have a little bit of time left, like 6 minutes. You probably could finish up that problem just using the second intersection value. You're only finding x because y is going to be negative 0.75. So you just write the x values. And then, again, the homework is to do those 4 graphs and then the 5 other graphs that are remaining on the worksheet that we were working on together in class. And I was hoping that somebody would like to present 4 and somebody would like to present 5 on the first worksheet, that page 18 worksheet.
Do I have to do another one?
Yes, would you like to do 4?
Sure.
Sure.
Wait, this is on 18.
Page 18, yes. I think you're good. Yeah, see, that's exciting, right? Grace, number 5. So page 18, the 5th graph on page 18.